So in example A, we're asked to factor the following equation. This is a binomial equation because it has two terms. So we're not looking at factoring it into two different parentheses. We're just looking for what's common in each term. So we're going to factor out the greatest common factor. So we're going to start with the coefficients and look at what is the largest number that is a factor of 21 and 14. So that's going to be a 7. With the r's, our greatest common r is r squared because we have 3 in the first term and 2 in the second term. And then with our s's, it's just one s. So when we are factoring out 7r squared s, think of it as if you're just dividing each term by your greatest common factor. And what's left over is what goes into our parentheses. So 21 divided by 7 is 3. With the r's, we have 3 in the numerator and 2 in the denominator. So we will be left with 1 in the numerator. And our s's, we have 2 in the numerator and 1 in the denominator. So we'll just be left with 1. With the right-hand term, 14 divided by 7 is 2. The r's are going to cancel because they're equivalent in the numerator and the denominator, and same with the s's. So our final answer is our greatest common factor, which we factored out, and then our parentheses of what's left over. Our next example is a trinomial. It has 3 terms, but we're not able to factor it right away into 2 parentheses because we actually have a greatest common factor. We always want to look for that greatest common factor first, and in this case, it's a c. So we're going to divide each term by c. Now you don't actually have to show this division, I'm just showing you so you understand what's happening. So we're going to factor out a c, and we're left with c squared minus c plus 2. We want to look to see if this factors any further. So we're trying to identify, are there numbers that multiply together to get positive 2, which is our c value, and those same 2 numbers add together to get negative 1, which is our b value. So if they're going to multiply to get a 2, we need either a positive number and a positive number, or a negative number and a negative number. And our factors can really only be 2 times 1. So there's no combination where we can add together to get negative 1, because if they're both positive, then they add together to get 3, and if they're both negative, then they add together to get negative 3. So it looks like this is our final answer.